Hello students, this is your physics teacher, Sir Glenmark A, and today we will solve a problem on the application of Newton's laws of motion. And this is the problem. A 3 kilogram box is allowed to slide from rest down the ramp that is inclined at 30 degrees. If the ramp is frictionless, what is the acceleration of the box? And what is the speed of the box upon reaching the bottom of the ramp 1.50 meters from its starting point? So this is the starting point of the box, and this is the bottom of the ramp, which is 1.50 meters from this starting point. To solve this problem, we will start by drawing the free body diagram of the box. Since the box is on the ramp, we will rotate our x and y axis so that the x-axis will be along the ramp and the y-axis will be in the direction of the normal force. So this is how we draw the free body diagram of the box. The x-axis is along the length of the ramp and the y-axis is in the direction of the normal force on the box. So this is the direction of the normal force, which is on the y-axis, and this is the x-axis. We'll take this direction as the positive x, and this direction, which is the direction down the ramp, as the negative x-axis. The weight of the box is directed perpendicular to the ground. So this is the location or the direction of the weight of the box. The angle 30 degrees is initially at this location. This angle, which is measured from the y-axis, is also equivalent to 30 degrees. Recall that the free body diagram is a diagram showing all the forces acting on the object. And for the box, the forces that act on it are the normal force and the weight. Now let us solve question letter A, the acceleration of the box. The box slides down the ramp, so its acceleration is along the x-axis, specifically along the negative x-axis. We will use the second law of motion, that is, summation of forces acting along x is equal to the mass of the object times its acceleration along the x-axis. In our free body diagram, the only force that acts along the x-axis is the x component of the weight W, which is this one. We will label this as WX. So the net force along x is equal to negative WX equals M times negative AX. This is negative WX because this is directed towards the negative x-axis, which is on the third quadrant. And this AX is also negative because the box slides downward towards the negative x-axis. So this is equal to negative M times G times sine of the angle 30 degrees equals M times negative AX. We can cancel M on both sides as well as the negative signs. So we have G times sine 30 degrees equals AX. We will input this in our calculator. So we have G, which is equal to 9.8 meters per second squared times sine 30 degrees. So AX is equal to 4.9 meters per second squared. So this is the acceleration of the box. Now let us solve question letter B. The speed of the box upon reaching the bottom of the ramp, which is 1.50 meters from the starting point of the box. In solving for the speed, we will determine both the x component and the y component of the velocity of the box at the bottom of the ramp. So we have v equals the square root of vx squared plus vy squared. To solve for vx, we will use the fourth equation of the motion with constant acceleration. That is, Vx is equal to the square root of V sub O x squared plus 2a times x minus x sub O, wherein V sub Ox is equal to 0 because the box starts from rest. So this is equal to 0 plus 2 times the acceleration of the box, which is equal to 4.9 meters per second squared times the length of the ramp, which is 1.50 meters. Using our calculator, we have 2 times 4.9 times 1.50 equals square root equals, we have Vx equals 3.83 meters per second. So this is the x component of the velocity of the box at the bottom of the ramp. Let us then solve for the y component of the velocity of the box at the bottom of the ramp. We will use the same form of the equation. We'll use Vy equals the square root of V sub Oy squared minus 2g times y minus y sub O, where again, the Voy is 0 because the box starts from rest. So this is square root of 0 minus 2 times 9.8 meters per second squared times y minus y sub O. Our y minus y sub O is equal to the length of the ramp times the sine of the angle 30 degrees. That is, it's equal to L times sine of 30 degrees. This is determined using the Pythagorean theorem. This is our y minus y sub O. This is the length of the ramp, and this is the angle 30 degrees. So we have y minus y sub O equals L times sine of the angle 30 degrees. This term is negative because this y minus y sub O is below the starting point. So we have 2 times 9.8 times 1.50 times sine 30 equals square root is 3.83 meters per second. So V is equal to Vx squared plus Vy squared and this is equal to 3.83 meters per second squared plus 3.83 meters per second squared. This is equal to 5.42 meters per second. So at the bottom of the ramp, the box has a speed of 5.42 meters per second.